Hello and welcome to the first video. In this video, I will be covering the initial prompt I gave to the AI to produce the first cut of the application's codebase. Before that, I thought it would be useful if I gave a short overview of the application, the latest version of which you can see running on the screen. My original plan was to develop an air traffic control type application, but it is probably more of a flight tracker application along the lines of Flight Radar 24. I chose this sort of application because it is adjacent to the system I work on professionally. The main goal was to experiment with the capabilities of AI for software development, where the AI is doing almost all the grunt work. That is, the AI generates everything that a human would traditionally create by hand. This means writing the code, executing the Git commands, writing the markdown documentation, etc. The main tasks I perform are acting as a product owner and performing quality assurance. When I say product owner, I am mainly referring to the action of defining the product goals or what features or bug fixes are implemented next and in what order. I think it is important to note that I do not, for the most part, act as the application architect. This role has been executed by the AI. For example, I did not suggest the application be built on Node.js and written in TypeScript. I did not make the decision to split the application into the Node.js workspaces the way the AI did. I have confirmed directions or approaches to take from time to time, but I generally take the advice of the AI. The AI I've been working with is OpenAI's GPT-5 Codex, which I've installed in VS Code. The development environment is Linux. The vast majority of my interaction with the AI is through Codex's VS Code interface, but I do from time to time use ChatGPT as well, as we'll see when I talk about generating the initial prompt later on in this video. And just to reiterate something I've already said, I haven't written a single line of code, configuration or documentation. All of that is done by Codex. The application you see running on the screen is the result of about 21 hours of my time working with Codex. The application can run in two modes. One mode where the tracks are injected by a simulation system, written by Codex of course, and a second mode that retrieves live tracks from OpenSky Network. The application is currently running in OpenSky Network mode, requesting data for South East Queensland, Australia. The first several videos in the series will show my experiences implementing some features that you can see on the screen. Before I asked Codex to generate code, I used ChatGPT to decide on an architecture for the application. You can see the first prompt on the screen now. After 20 seconds, ChatGPT recommended two options. Number one, a web stack built on React, TypeScript, MapLibre GLGS, and DeckGL. And option 2, a desktop stack built on Qt6, QML, and QMapLibre. It recommended the web stack approach. After I asked a series of follow-on questions, I took ChatGPT's advice to implement the web stack approach. Once this decision had been made, I then asked ChatGPT to create a prompt for Codex to implement this solution. You can see the second prompt on the screen now. ChatGPT's response was very long. I copied the ChatGPT generated prompt into Codex and let it create the application. Unfortunately, at this time I wasn't planning on creating videos about my AI coding experiences, so I did not record the execution. However, looking at the Codex session logs, it looks like Codex took 27 minutes to complete the request. I suspect that the initial codebase created was around 70 files and 3,500 lines of code, config files, and documentation. The initial cut of the application did not build, and when I did get it building, it had several bugs that needed to be addressed. The version you see on the screen shows an early build that has about 4 hours of work after the initial prompt. It took me about 7 hours working with Codex to produce a working product that displayed the map properly with simulated tracks overlaid. That is the end of this video. In future videos, I will show examples of implementing new features and fixing bugs.